would like to welcome you all to this third ALASCA Tech-Talk. My name is Maria Vaquero from Cloud and Heat, which is one of the founding members of the ALASCA Association, and I'm going to be moderating today's talk. Please remember that the session is going to be recorded and that it will be uploaded on YouTube, so just so that you are aware. You should have received a notice anyway when you joined the room. Just to start with the agenda, which is similar as usual. We will have an introduction, very short introduction on the Tech Talks for those of you who are joining today for the first time. Then we will have the core of the session today, which is a Tech Talk by SysEleven. And then we will share some events and news that might be interesting to the rest of the community, and also tell you what's coming up in the next weeks in Alaska. So what are the ALASCA Tech Talks? Some of you already know this if you've joined the Tech Talks before, but if any of you are joining today for the first time, they are an open platform where people, companies, organizations that have an interest in cloud technologies, that have a potential to improve the openness, scalability, digital sovereignty. So these people and these companies can share what they're working on, can share their projects, and maybe create a room for future collaborations and just to learn what's happening outside of our firms or our organizations. It's important to know that this participation in the Tech Talks is open, so anyone who wants to join can participate as a listener, or also to ask questions and so on. It's also open for those of you who want to present something. So if you have an idea of something that you want to present, you can also present it in the Tech Talks. Just we will let you know later on how to communicate that you want to present something. And just very briefly, the history, the Tech Talk started last year, I think sometime in spring. They were originally hosted by Cloud and Heat Technologies because we were working on a project with other partners, and well, after the project, we thought it would be really interesting to keep on discussing and sharing what we're working on. And so that was the first seed for the Tech Talks. And since 2023, they've moved on to the ALASCA Association, which was created at the beginning of this year by 7 founding members. And so now it's hosted by ALASCA. If you want to receive information on the next ALASCA Tech Talks, there's several things you can do. First, you can visit the ALASCA website, where we post all the information on the upcoming talks, and you can also download a calendar file. If you want us to send you a monthly calendar invitation, then just let us know. You have here the email, hello@alaska.cloud, and then we will add you to a mailing list, and then you will receive the information on a monthly basis, so that you don't have to look it up especially. And then if you miss a Tech Talk and you want to watch it later on, please visit the ALASCA YouTube channel, where we upload the presentations a couple of days after each Tech Talk, and then you can watch them there, or you can share it with anyone who's interested in watching them. So this is so far the information on the talks in general, and now I will just move on to the Tech Talk that we have today. So Christoph Glaubitz from SysEleven will be presenting a very interesting topic today. He's an infrastructure engineer, and he's going to talk about how to build a maintainable network fabric. I have here a couple of bullet points as a spoiler, but maybe since he's going to speak right now, I will skip the bullet points and give the microphone over to Chris to start his presentation. So whenever you're ready, I will stop sharing, and then you can start your presentation, and then we will have some questions and answers at the end.
Thanks, Maria, for the introduction. I will try to share my screen here, the correct windows, I hope. So my name is Christoph Glaubitz, or Chris. however you would like to call me. And I would like to show you how we are building our network fabric so that you can see where we come from and what we are dealing with today and maybe potential changes in the future. So I will give you a quick introduction into our way to layer 3. I will give you a small demo that runs on virtual machines. So in theory, everyone could try it in virtual machines as well. And I would give you some points regarding to Kubernetes and OpenStack and some challenges you are going to face when you do something different than just what everyone else is doing. We had a couple of ideas when we were building the first layer 3 fabrics in the company that dates back about, I think, 10-ish years. I'm not quite sure, but about that. We wanted to have something that was maintainable, that was scalable, and that was, to a certain extent, vendor neutral, so that we can swap out whatever switch vendor we have for another one. That were the main goals. And I want to show you how we got there. So first of all, we started with a usual setup back in the day. Today, the setup might be a little bit different because you have more than one network card connected to a node. But at the time, we had one network card. And they were connected to a top-of-rack switch, which was solely layer 2. And it worked reasonably well for quite a while. Did not provide many features, but didn't break as well because it was simple. We scaled, we had multiple racks, we needed to connect those racks. Our layer 2 domain grew and grew and grew, and everything became a little bit more brittle, I would say, and features were lacking. We faced the feature lacks more and more, and it was quite complex to maintain. Routing was a little bit, cabling was a little bit more difficult than it was before, and everything tends to fall apart. Then we came up with the idea of a Clos Fabric. Clos Fabric is, if you're interested in the history, it dates back to the first telecommunication networks. So I would recommend you to search on the internet for Clos networks, because it's quite an interesting history and dates back to telephony and how they are connected in the telecom operation things by humans that plug in a cable here from there, and then you got the connection. And the entire Clos Fabric stems from that time, and it's a fun experience to read about that. Anyways, the setup we are using is we extended an area with spine switches and have our top-of-rack or leaf switches in the speech of a Clos Fabric or a leaf spine architecture. So we were able to connect two switches and could scale out the racks even further than we could before. Everything always depends on the number of ports that we have available in those switches, and that are the limitations of scale. Then you can put another layer on top of that for sure, but those are the constraints you're currently dealing with. So in this setup, you might see that layer 2 not work quite as good as it was before. So we needed a way to have routes to the nodes propagated somehow, so that every way from one node to the other would be routable and reachable. For that, we introduced BGP in our fabric, which gave us the flexibility that we can propagate routes, we can withdraw routes, and everything works good enough. So the only thing that lacks in that setup is if you lose a node, you still lose a node. But on the rest of the setup is pretty fail tolerant. We can cut whatever cable and everything would work the other way. Like when the traffic from that node to that node can flow over this cable and then down here. And if one of those is cut, it could also go over this cable and here. So we can lose one switch of the spine area, and we would be still able to reach nodes in the other racks, which is already a pretty good achievement. But we can go further. Like we have something that is maintainable already. It is scalable and it is vendor neutral due to the use of BGP. BGP, every vendor these days can talk or can be configured to talk to. You can even set up such things like I show you in a second with virtual machines that must not be special hardware, and it would run on an OpenVRT router as well. So it's nothing really complicated. But we thought, can we turn the screw a little bit further, and came up with the idea you see here. So we don't just connect the node to the top of rack switch in the same rack, but also cross cable each node to the top of rack switch in the rack right beside of that. We have one more network card for sure to have the connection, but we shrink our layer 2 domain here tremendously. Now our layer 2 domain is just those tiny cables here. And in the initial drafts we have a transfer network on those links. We run BGP on the nodes and we expose routes to the switches. And with that way, everything is reachable. And even if one of those cables will go down, we can just take the other way to the node. And BGP is responsible for tearing the routes down and directing the traffic to over the other switch. In the early days, we used IPv4, or we still use IPv4 on that, but these days it is possible to configure it solely with IPv6 link local addresses. This is what I'm going to show you today. That makes vendor neutrality, again, a little bit not difficult, but limits it, I would say. Because, for instance, if you use the BERT BGP daemon, that is not capable of doing that, while FRR can do it. Like the Mellanox switches, you might know, are capable of doing that. Juniper can do that. Cisco can do that. So you limit yourself just a little tiny bit. So it's not a real problem. Okay. With that, I would go onto a terminal if I can find it here somewhere. And the question is that large enough here? Can you all see that?
Yeah,
no.
right now we can see.
Okay, and it's large enough.
Okay, yeah, it's large. Yeah.
Okay, so what we see here, we have in the left corner we have a compute node. In the right corner we have another compute node. That were the nodes that you were seeing here. Let's say 2 of those. And then I have 2 switches. And that's basically it. For the demonstration, I skipped the spine area because it would just be too much to model, and we stick with such an setup here plus such an setup there. Okay, then let's see how a node looks like from the perspective of the admin. So I'm connected to them via, let's say, a management interface. And I have 2 other interfaces here, which is ENS4 and ENS5. ENS4 is connected to switch 0, while ENS5 is connected to switch 1. The same is true on the other compute node. So, excuse me. So the IP addresses on those interfaces, you see there's nothing configured at all. It's just the link local IPv6 address that comes up on every modern computer, but nothing more. When I now will configure an interface which holds an IP address, which then will be the reachable IP address of that particular node. So yeah, I go to the other computer and issue a ping to the IP address that we are going to use there. This is the IP address I will assign on the other side. So to make things simple, we just create a dummy device called Fabric, because, well, Fabric is a nice name. So now we have that interface running. We assign an IP address on that, and I start my my BGP suite. Just to show you the Fabric interface, we have the IP address assigned to it, and you already see that the ping now comes through to that node. I can show you that it comes here. So, okay. So far, so good. Let's take a look at the routing table here, because when we look here, I don't have any IPv4 addresses here, but I have an IPv4 address here, which is my reachable address. And as we can see, we have an IP address range that was announced via BGP by our switches. And we can see that this particular route has two ways to go. This is the one switch, this is the other one. As a demonstration, when I stop the system, the BGP suite here, we see that it's only one route available. As soon as we restart it again, it will take a while until it converges, but at some point we see it again that both links are there, or both ways are established again. So I will show you a TCP dump on both of them, because so that you can see the flow of the packets. So I started the ping, and you see all packets are traveling through one of the instances. And as we saw before, they will appear here as well. So it goes from compute 1 to switch 1 to compute 0. That's already pretty good, but we can do even more here, because currently it's just the computer on compute 1 selected a route and is sending the traffic over there. There is another concept called equal cost multipath, because when we switch back here, we see that the destination of two nodes is pretty much always the exact same distance. If the packet travels that way and goes out that way, it's equally far away as that way and then going that way. And because of that, we can use equal cost multipath for that. And I will enable that. And what we can see here now is interesting, because on one switch, we see all the echo request packages, while on the other, we see all echo reply packages. So now both of the switches are currently serving some traffic. And we haven't seen any interruption in the ping above. It just all works transparently. We did something on our internet, on our connection, and the customer haven't detected anything about that. Same as if I stop the BGP suite, we can see that all of a sudden everything runs only through that one switch. We can't see any packets here anymore. And the customer didn't even notice. No packet was lost on the way. And that plays very well with all the overlay networks we are seeing these days. If it's Kubernetes or if it's OpenStack, everything works kind of the same. I'll just re-enable that. So I will show you as an example in the VXLAN tunnel that we can shoot from that one node to the other. So what we did now is we created an overlay network over, that's solely a layer 2 network. We put it over our layer 3 network. This is what OpenStack would do. In older implementations, it would be VXLAN. In newer implementations, it would be Genève, but the idea is pretty much the same. We can now ping from that side the other side. And the interesting thing here is we would see the traffic is kind of like that, when I'm not mistaken. Well, the ping is just flowing here at the moment. So what we have now is an entire overlay network, and you can see that it is VXLAN, and we have an ICMP packet in it. And we can also see the IP addresses that are used here. Here are the IP addresses of the tunnel, and here are the real IP addresses of the node. Again, the IP addresses on the node are not really on a physical interface, but on our dummy interface. So, and again here, if I just double check that the packets are flowing here, if I stop that, everything continues to work, and the packets are flowing over the other switch. If we this is very easy, so that we can just lose one switch. If we stop it and lose both switches, for sure, everything is stalled because we have no connection anymore. So it's always a matter of taking a little bit care of the systems you have, but in general, it is relatively bulletproof, so that we can maintain individual switches without risking any of the customer traffic that flows over our entire system. Okay, here our packets continue to flow as soon as the session's established again. And again, if we start the other one as well, everything just keeps flowing. Okay, I will switch back to my slides. So what about Kubernetes and OpenStack? It's not too complicated, and both of them work relatively well in that setup. In Kubernetes, it is just a matter of configuring the node IP. The node IP must be the IP address that the node should be reachable, so our address that I assigned to the Fabric interface. With the entire setup, all of a sudden routable pods became possible. So I can, the system tell not only to export, like we can see here, to announce my IP address that I have here. This is the IP address that we currently announce, but I can also announce an entire podnets of the particular node, for instance. With that, I can all of a sudden build a routable pods without doing anything, just leaving away the VXLAN or the IP tunnel. The nice thing about that is we don't need an entire BGP full mesh, which you would potentially see if you would use Cilium that builds a BGP setup, BGP connection between all of the nodes and then propagate routes there. We don't need it because the switches in our case do all the heavy lifting for us. The downside of that is the BGP routing agent must be there on the system before the node joins the cluster, because it must be reachable over that node IP address. So there are trade-offs everywhere. And the functionality depends a little bit on the CNI. So when you have something like Cilium, it is possible. If you use Flannel, it's, I think, a little bit more complicated to leave away the VXLAN overlay, but it works in general. For OpenStack, it's the same. Every compute node must just configure the my IP address, and Neutron, I think, as well. I don't know if it's also my IP address, but the VXLAN tunnels are then shot like I showed you here from over the Fabric IP addresses. That is something that OpenStack then takes care of. You don't have to do that, or Neutron takes care of, as long as the configuration is correct of the my IP field. And everything just works. You don't have to do anything more. And I'm running such setups with OpenStack underneath that for about 8-9 years now, and never faced any problems. Well, that's a lie for sure, but not so many problems. Again, here, nothing comes for free. We have a steep learning curve, so you must have a general understanding of BGP. You must have some more understanding about routing and route propagation. You have more software to configure and maintain. Masquerading is going to be a huge problem when you deal with things in Kubernetes, for instance, and things rely heavily on masquerade. You will face some issues because when the packet that's going to be masqueraded leaves a particular interface, then it will get the IP address that's assigned to the interface and not our Fabric IP address or the node IP address. That is something you must account for. And sometimes I don't know how the situation is today with many of those CNIs, but some years ago, for many CNIs, you needed to sneak in some source node rules right before the masquerading rules because it just didn't work. I was not able to configure. These days, I think it's a little bit better. So like Calico provides a mechanism to configure that, Cilium as well. The configuration, some configuration issues can unfold a little bit later because, as I mentioned to you in the previous slides, we used /30 nets IPv4 addresses for the transfer nets, but they were somehow routable at some points. And we had, for instance, that MySQL Galera cluster was connecting over the wrong IP addresses, and we didn't realize and rebooted the switch. And all of a sudden, the Galera cluster was broken because of a misconfiguration. But that's not that common if you use IPv6 link local addresses. Especially in Kubernetes, multiple BGP speakers might become a little bit more complicated because they usually BGP uses the same port. It's 179. And if you have the Fabric BGP running underneath, and then you would like to start a BGP speaker for whatever other reason and connect to something else, you might need to change some ports. But it's a configuration issue, and the computers, it says you that you're in trouble. It doesn't start the services. Okay. We do it for quite a while now. Like I told you, for OpenStack, like 8 or 9 years, and about 10 years in general in our Fabric. I was watching the TalosCon last week or the week before, and you might see some similarities here from what we were building, because it's exactly the same, except for they have one switch more. They talk here about 2 top-of-rack switches instead of 1, but technically it's exactly the same here. It's a deep spine fabric or a Clos Fabric, and they can slice and dice clusters horizontally and don't care about which nodes is in which rack. That's all possible with those fabrics. We have Red Hat OpenStack 17, and you might be familiar by now with this kind of cabling and switch naming, because, well, it's exactly the same. Meta is doing it as well for quite a while. It's also similar. So we are no unicorns here. And even before us, people were doing it in the exact same way. So it's nothing really special here. Okay. That was it. And I want to hear some questions from you folks.
Thank you very much for the presentation. From my limited perspective, it does really seem like a very steep learning curve. Are there any questions from the audience?
Niklas?
Yes, so you've shown a bunch of UDP and ICMP packets. I'm not too familiar with ECMP yet, so how is packet ordering assured when you do a TCP connection through the VXLAN over 2 different routes?
In that case, there was one route picked. I haven't checked that, but the flows are established. When a flow is established, it will remain the same, so it will not change. If you establish a new flow, that will go over a different connection. Like, let's say you talk from one VM to the other and establish a continuous flow between them. It goes over one connection. If you talk another flow from the same VM to the other VM, it might go over the other link. So does that answer your question?
Oh, okay.
So the flows are not mixed. If a flow is established, it remains over the thing, but no new flows are distributed kind of evenly.
Yeah, but how's the flow identified? Like, are you actually looking into the VXLAN packets as well?
I can't answer that. That's something that Linux does for us. Sorry.
Okay.
That was the setting I was setting here. This one that takes care of that. So, but I don't know what happens under the covers.
Okay. Are there any other questions? I saw another hand, and then I stopped seeing the hand, and I cannot remember who it was. I don't know if it was a mistake or...
No more questions?
Everyone is highly impressed by the demo. Okay. So if there are no more questions, then we can move on to the closing remarks of the session. Okay. Okay, Chris, thank you very much for the presentation. Maybe if there are any questions afterwards, people can contact you.
Yeah, definitely. Please reach out.
Okay, great. Thanks. So I'll share again. 1 second, please. Okay, so if you enjoyed the talk right now and you think you have also something that you would like to present, please let us know. You can send us an email to hello@alaska.cloud, and then we can plan your talk for the next months. We already have 1 or 2 planned, but for the upcoming months we can plan your talk. And if you are unsure, you have maybe an idea, but you're not sure what the correct focus would be, then also just let us know, because we maybe help you with defining a talk that would be relevant for the audience. And then we have this short session on news and events that we always share with you. First, I would just let you know that if you have any event or news that you would like to share with the community, you can just speak up now. So this is a part of the talk that is open for any news or any events that you think might be relevant. So please speak up if you have anything that you think you would like to share with the rest. Otherwise, if you have in the future other events or other news that you would like to share, you can also let us know in advance, and then we can put it into the slides. What we wanted to share with you was first that 2 weeks ago, we had Alaska's first conference with the CloudFest, where Alaska presented itself, its mission and activities, what Alaska is working on. You see here a picture of our colleague Ariane presenting at the conference, and yeah, it was also a very good opportunity. Maybe I know some of you were also at the CloudFest and shared these discussions on how to drive open source and how to improve digital sovereignty. So that was a first for Alaska. And then what we have upcoming is also a newsletter that will be launched on a quarterly basis, where we will share information on the latest news and events and the Alaska projects. So currently mainly Yauk, which we presented in the first Tech Talk of the year. The newsletter can be downloaded, or will be able to be downloaded when it's ready from the website. If you want to receive it by email, then just also send us an email to hello@alaska.cloud, and we will put you on the mailing list. And then we also have from the community, so specifically from Cloud and Heat, an event that we would like to inform you about. It's the Green Ideas After Work event in Berlin. It will take place on the 20th of April. And it's a free event for anyone who wants to join, where we will discuss topics related to artificial intelligence and sustainability. So how to make artificial intelligence more sustainable, and how artificial intelligence can also contribute to improving sustainability. So that's also maybe an event that might be interesting for some of you. Are there any other events or any other news from anyone that can be shared right now? Okay, it doesn't seem to be the case, but as I said, if you have anything that you would like to share in the future, then just send us an email yeah, before the next Tech Talk, and we will add this to the presentation. Okay, so with this, we're almost ready for today. The next Tech Talk will be on April 27th. So it's always on the last Thursday of the month. always at 2 p.m. And for the next session, we have a presentation by the nation. So Martin Pilka and Matej Feder will be presenting in the next Tech Talk, and they will talk on how they transform the Kubernetes-based infrastructure from Terraform Ansible manual interventions to the cluster API approach. So that's the next Tech Talk, and as I said before, you can follow the information on the website. You can also follow ALASCA on LinkedIn and get all the updates. And if you want to if you want us to add you to the mailing list to receive all the invitations for the next Tech Talks, then just send us an email. Otherwise, I think we're done for today. Thank you very much to everyone for joining. Thank you particularly to Chris for the very interesting presentation.
Thanks for having me.
Yeah, you're welcome. And I hope to see all of you in 1 month more or less, 4 weeks.